Factoring with first term coefficients, ax squared plus or minus bx plus or minus c is a trinomial. And what we're going to look at today is when the a is not 1, it's another number. My question, should you always jump to the diamond method when you have to factor a trinomial? My answer is yes to that. Because once you take out a greatest common factor, really the only way to get those two binomials easily is to use the diamond method. So let's remember that the diamond method is a tool. It's not the final factoring. It's not the solution to the problem. So when we're looking at this trinomial, 3x squared plus 5x plus 2, we're going to take that a and c, and we're going to multiply them together. So 3 times 2, so we'll put a positive 6 up on top. On the bottom, we'll go the positive 5. So we need two numbers that multiply together to give us 6 and add together to give us 5. So that would be the numbers 3 and 2. If we use these numbers, 3 and 2, to rewrite this trinomial so that we have 4 terms, we would end up with 3x squared plus 3x plus 2x plus 2. Remember, we're just using that diamond to rewrite these middle terms. Now we're going to factor by grouping by looking at the left-hand side, 3x squared plus 3x, and we're going to pull out the common factor, which is 3 and an x, leaving behind x plus 1. If we put x plus 1 onto the other side, we would multiply that times positive 2 to get 2x plus 2. So our two binomials, the common x plus 1, and the other, the remaining 3x plus 2. I can prove to you that this indeed is the prime factorization, these binomials of this trinomial, by multiplying back out. X times 3x is 3x squared, x times 2 is 2x, 1 times 3x is 3x, and 1 times 2 is 2. We add up all those terms, 3x squared plus 5x plus 2, and you can see that's back where we started. So by using this AC and times B, we should be able to use that diamond and work effectively to find those two factors or those two binomials. So let's take a look at this. 6x squared plus 7x plus 2. We're going to put 6 times 2 on top, 7 on the bottom, and then we're going to multiply, which would be 4 times 3 would give us 12, and add together to give us 7. So we're going to rewrite the middle section. So 6x squared plus 4x plus 3x plus 2. What we'll do is cut that in half and take a look at the left-hand side. 6x squared plus 4x, the greatest common factor is a 2 and an x. That leaves behind 2 times 3 would give us 6, and we need one more x. And 2 times 2 would give us 4, and the x comes with us. Write that same binomial, 3x plus 2, on the other side. Multiply that times 1, and we'd end up with the two binomials, 3x plus 2 and 2x plus 1. Let's take a look at it a little differently. Let's change that c to be a negative c. So we'd end up with 2 times negative 12, which is negative 24. And then on the bottom, that would be positive 5. Because this is negative, we're going to need a positive sign and a negative sign. And we're going to be looking for factors that their difference is 5. So let's write down things that give us 24. We know 24 and 1, 12 and 2, 8 and 3. I think I stumbled upon it right there, 8 and 3. And since we want more positives, we want the 8 to be positive and 3 to be negative. These will be our two replacement factors when we put in here for 5x for that term. So let's rewrite 2x squared plus 8x minus 3x minus 12. We're going to cut it in half. Take a look at the left side. 2x squared plus 8x comes out a 2 and an x. Leaves behind an x plus 4. Write that binomial on the other side, x plus 4. We would multiply this times negative 3 to get negative 3x minus 12. So our two binomials are x plus 4 and 2x minus 3. Let's take a look at another one. This time we'll have a negative b and a negative c. Let's do both of them that way. So 6 times negative 7 is negative 42, and this is negative 41. Now, because this is negative and this is negative, we need one of each. And here's something to notice. The closer these two numbers are, the top and the bottom of the diamond, the further away the two numbers are in between. So that's kind of something to think about as far as patterns. So the two numbers then that are close together would be 42 times 1. And so since I would need a more negatives, I would put 42 here and 1 there. So that's kind of a little pattern that we can spot. So let's rewrite 6x squared plus x minus 42x minus 7. And again, it doesn't matter which order you put those factors in there, or I should say rewriting the terms in there, because the commutative property lets you go either way. So if you prefer to put 42 first and then 1 second, whatever works for you works out. It doesn't really matter. Okay, well, here we're going to factor out our common factor, which is x, leaves behind a 6x plus 1. We write 6x plus 1 on the other side. Here we would multiply by negative 7. So our two binomials are 6x plus 1 and x minus 7. Let's take a look at one more. Let's have the c be positive and the b be negative this time. So what that does is gives us so 36 times 3, and I'm going to do some work on the side here. It's going to be 108. And then that's positive 108. And down here we're going to have negative 21. Now, because of that, these are both going to be negative. Now, we could see and notice that, gosh, these numbers are really, really big. And who really wants to do big numbers? I don't. So what we want to do then is think about this, and that's why I have this question up here. Could we have maybe found a greatest common factor in here first? Well, let's go back and look. 3x squared minus 21x plus 3x. Yes, there's a 3 in common. So let's factor out that 3 first. That's going to leave us behind x squared minus 7x plus 12, which is way easier to work with than this original, because who wants to find factors of 108 that give us, that together they add up to 21? That's a tough thing to do. But now, when we're in this mode, we've already pulled out the 3. All we have to do is look here, and we say, okay, I need a positive 12 and a negative 7 to rewrite that middle term. And then these will also still be negative. So again, we're back to that 4 and 3, because 4 times 3 is 12. And so I go to rewrite this. So when I rewrite it, I'm going to carry that 3 with me the whole time, because it's part of that factorization. Remember the factor tree. It's all together. So we're going to rewrite that middle term, x squared minus 4x minus 3x plus 12. And we're going to cut it in half and take a look at that left side. So we're going to keep the 3. And here we're going to pull out an x, leaves behind an x minus 4. Put an x minus 4 on the other side here. And then here I would multiply by negative 3. So then altogether I'd have 3 times x minus 3 times x minus 4. This would be my complete factorization of that trinomial 3x squared minus 21x plus 36. So again, if you get big numbers, take a step back and think, is it something you could factor out earlier? And then if so, then it makes it so much easier for you. So let's take a look at something else now called a difference of squares. Now, we remember from our previous chapter that this would be the difference of squares, just x squared minus 25. The reason it's called a difference of squares is because of the minus sign between them, and because x squared is a square, and so is 25. 25 is a square because it's 5 squared. So we know this, and what that's going to do is it's going to help us in order to factor it if we have this knowledge. We can take a look and say, well, we're going to split them. We'll take those different signs. We'll put a minus sign and a plus sign. We'll take the x's and we'll split them, and we'll put an x and x, and the 25 will split with 5 and 5. If we follow this pattern, then we know that it's something simple to do. Again, just remembering that this is x squared minus 5 squared, putting 1 in each one. Now again, I can prove to you that this works out the way it does, because x times x is x squared, x times 5 is 5x, negative 5 times x is negative 5x, and negative 5 times 5 is negative 25. And you can see that middle term is going to go away, leaving behind x squared minus 25, which is what we started with. So let's take a look at a couple problems and being able to know right away what that factors are, what those two binomials are. So in difference of squares, remember, it's a binomial. The others were trinomials, but this is a binomial. So when we take a look at this, x squared minus 36, we recognize that there's a minus sign, a square, and 36 is 6 squared, isn't it? So what we would do is write down our two binomials. We know one needs a minus sign and one needs a plus sign. Doesn't matter which is which. We would put an x in front, and we would take the square root of 36, which is 6, and we would drop 1 in each one, and this would be our factorization. To make it a little bit harder, here we have 49x squared minus 81, but the same rules apply because I can take the square root of 49, because that would be 7 squared. Same thing with 81. That would be 9 squared. So I can write my two binomials. I know that one will be a minus sign and one will be a plus sign. And so this one will be a 7x in each spot, because 7x times 7x will give us 49x squared. And here we put a 9 in each spot, because 9 times 9 is 81, and we're done. So hopefully this helps you in factoring trinomials that have a number larger than 1 in the A spot, and also being able to recognize difference of squares.